This is going to be our third session, our last session of this three-part series, the Salesforce Developer Brick Road. I'm going to share with you the presentation. You'll be able to see it in your screen right now. This is episode number 3. Without further ado, I know that some of you have already seen these slides in the first day, so I'm going to give a quick introduction about Ascendix, the company I work for, and about myself. Ascendix was founded in 1996. These are our two founders, Wes and Todd. Our company is originally from Dallas, Texas, but now we have offices in Ukraine and here in Portugal. This partnership has yielded over 200 companies implemented, developed, and customized CRM systems with us for more than 20 years. Ascendix by numbers, we have over 25 years experience in CRM consulting and custom software development with over 17 CRM products and apps. Our major platforms we work with are the Microsoft Dynamics CRM system and, of course, Salesforce. We have over 15 years experience in IT outsourcing, serving over 20 countries with more than 10 CRM platforms and with a team of over 200 highly experienced and skilled employees. Some of them are here with us. Welcome. Thank you for joining us. This is myself. I'm Luis Andrade. I'm 29 years old, turning 30 this year. I am originally from São Paulo in Brazil, but I've been living here in Porto for the last year and a half. I hold a degree in systems analysis and development and have worked in the Salesforce ecosystem for the past 8 years, holding multiple positions at world-class companies as analyst, developer, and consultant. I've been working with Ascendix since November 2021 as a lead consultant for Portugal, and I was actually the first official employee here in Portugal. These are my contact information if you'd like to get in touch at a later date. This is my email address and my LinkedIn profile, so feel free to get in touch at any time. Previously on the Salesforce Developer Brick Road, what we've seen in the past 2 days. First, what is a program? The structure, the basic structure of an Apex class, including syntax, variables, data types. We have seen selection structures such as if, else if, and switch case, collection variables, arrays, lists, sets, maps, iteration structures for while and do while, visibility and scopes, SOQL queries, including aggregate queries, how to do database operations in Apex code, and how to place comments in that code. Today, our main topics is going to be test classes and coverage. This is going to be most of our presentation today. First, what is a test class? Every Apex class and trigger must be covered by automated tests. So these test classes, they automate testing our code. The minimum coverage for deployment is 75% for business classes and 1% for triggers. So they must be at least covered in some way. The test classes should be deployed together with the business classes and triggers in order for us to pass those tests. We usually place them in the same package or the same change set. We should always strive for 100% coverage. So for every conditional or any if statement, you should test both the if and else clauses. The test classes execute the class's methods and compare their results to known and expected values. And if there's a mismatch, something's wrong with the class. Test classes and test methods must be marked as such with the annotation @isTest, which you'll see highlighted in green in this little example we've got here in this slide. So let me share my screen with you. This class is also here in my developer console. Here, share screen number 2. So here's my developer console. this is a test class. This is my example class. So what is it doing here? There's a single method called number average. It calculates the average of a list of numbers. So we've got a list double here, a list of numbers. It creates an accumulator, and for each number in the list, it first tests if the current number is negative. If it is, it returns null and halts the execution. Otherwise, it sums the current number to the accumulator. Then after going through all the numbers in the list, it divides the sum by the quantity of numbers, the size of the list, and returns the average. So that's what our business class is doing here. So let's write a test class for it, which is our example test class here. We're going to start out by simply running it with valid arguments. So I'm putting here 4.4 and 6.6, and I run it with this instruction here. When you annotate your test class as with the annotation @isTest and you save it, the run test button is available here. So when you click it, it runs the test. Let's do this. All right, so here is our test class. Let's check its results now. You'll see that here there's a panel in the bottom of my screen here, which is tests. The status is a green check mark, which says that the test has run completely without any errors or exceptions. So it looks good. These are the results of our tests. This is a comparison, just so you see the business class and the test class here. And now let's check the coverage of the test class, which we have here. So let's go back into the example class, the business class here. Let me close up these other. So here it is. When you click the code coverage button in the upper left corner of your screen, there is here all tests 85%. So that's the coverage percentage. And you'll see that the lines that are covered are highlighted in blue, and the ones that are not covered are highlighted in red. In this case, you'll see that our test class has positive numbers, but it has no negative numbers. So this clause here, this conditional here, when we receive a negative number, it doesn't happen. So let's write now a test that also covers this other clause. I actually have it ready here, so I'm just going to copy and paste it. So just let me correct the indentation here and save it. So now we've got a test. We're running this test class with a negative number. One thing that should be noticed is that not necessarily the relationship between the number of test methods and the number of business methods, it's not necessarily one-to-one. So you can have multiple tests for one given method, and you can have one test method that tests multiple business methods. So it's all a matter of how you plan your tests. There is no rule about this. Our test class is saved, so let's run it again to see what happens. Run again, success. You'll see that now the total of tests that have been executed is 2. Both have executed successfully. Let's get back to our business class and click code coverage. You'll see that now we have 100% coverage. All right. So Are we done? Is it enough? No, it's not, because as I've said previously, the test classes should not only cover the lines that are written, but they should compare the results that are given by our business method to a known good result. Let's go over these lines. So the results aren't compared to anything right now. The method that provides comparison facilities is called system.assert. You'll see that it takes two arguments. The first one is the comparison. So I'm comparing here in line 12, the result that has been returned by the example class number average to 5.5, because, well, if you take a simple handheld calculator, you add 4.4 and 6.6 is going to give you 11. Divide by 2, 5.5. So that's the good result. The string here, which is the second argument, is the error message that appears in the test panel if the comparison fails. So let's add the assertions to our test methods here. So we have example test class. And there's a second assertion here. Saving the class. And now let's run it. Since we are doing the correct things here, the test runs successfully. But let's make them fail so you can see what happens. So I'm going to provide another different expected result, which I know it's incorrect, but no matter. You'll see that the red cross here, so the test hasn't executed successfully. I'm going to expand here, double click this one, and you'll see here, errors. Assertion failed, average calculation is incorrect, which is the exact message we have set here. So that's how assertions work. Triggers. What are triggers? We have talked about triggers previously. A trigger is a piece of code, a program that runs before or after a creation, update, or deletion of a record is required on the system. No user intervention is necessary for their execution. They run automatically. They are called by the database. Triggers should be planned in the context of multiple records being operated at the same time, say via data loader. I mean, you're dealing with 200 records at the same time, so you should always think when you're writing the code that you are dealing with multiple records at the same time, and so we use lists and loops in order to cater for those multiple records. Aggregating operation is key not to surpass any limits. In particular, the 100 query limit, the 100 DML operation limit, and the 120-second limit for Apex CPU time. Changes made to the record itself within the context of a before trigger need not be committed. You'll see that in a minute. This is the Salesforce order of execution when you are saving a record, updating, creating, anything like this. This infographic has been made by Salesforce Ben. Some of you might have seen these before. So let's take the parts that we're going to use. So before triggers is step 4 here, highlighted in red. They run prior to the record being saved to the database. So they prepare the record for being saved. And these triggers are mostly used for field updates and validations. Some of you might think, shouldn't I be using declarative development like workflow rules and process builders and flows and stuff like this, the formulas for validation in order to do these validations? Yes, you should, but they have some limitations. Say you want to ensure that a record has just one related record to it, and you can use a query here in a before trigger in order to validate that there's a single related record, say. So Apex allows you for more flexibility. You cannot do this use case with a formula, and you should be doing. You will need to do this via Apex. So after triggers, which are number 8 here, they run after the record is saved, but they're not yet committed to the database. Let's make here a small definition. Being saved to the database means tell the database, these are the new values for this new record, but we're going to do a little more stuff, so don't save them yet in your hard drives or SSD or any other storage. So it's saved but not yet committed. These after triggers here, they are usually consequences to of the changes that we are making to the record that's being saved. We usually use them for making changes to related records, sending emails, integrating with external systems via callouts, that kind of stuff. So they do not operate on values on the record itself. If any error happens, be here on before triggers or in after triggers, if any exception happens or any other bad stuff, the commitment of records to the database is halted. So remember that the record has been saved on step 7 here, but not yet committed. The commitment is made as the last step. Yeah, it's number 18, commits all DML to the database. So if anything bad happens, the record is not committed and it's rolled back to its original values. And how do we write triggers? So let's get back into our developer console. So we come here, File, New Apex Trigger. We provide a name to this trigger, and we attach it to one of the S objects, which you might select here. So this is a trigger on account. By the way, good practice says that you should have just one trigger per object, mostly because first, multiple triggers do not have a predictable execution order. And second is that it makes it easier for maintenance. These are some of the main elements of the trigger. So account is the object. The events are listed here: before insert, before update, after insert, after update, after delete. Triggers have no methods, so they're just executed. Each object should have only one trigger. We've already talked about it. The values trigger dot is before and trigger dot is after, which you can see here in green. They are Boolean values that are set according to the moment the trigger is being executed. So is before is set to true if this trigger is executed before, and the commitment, the saving, and after, likewise for after the saved. Differentiating between the database events is done via the variables trigger.isInsert, trigger.isUpdate, trigger.isDelete. For upsert operations, they are executed for one of these events. The insert part is executed when you are creating a new record, and the update when you're creating a new record. So it works also for that scenario. There are two other variables, which are trigger.old and trigger.new. Trigger.old contains the records such as they were before the modifications that are being made. So these are the old records. And trigger.new contains the new values that you are trying to save to the database. Trigger.old map and trigger.new map contains those same values, but instead of being a list, they are a map with the IDs and the records themselves. Which ones you want to use, that's up to you. It's mostly related to at which point in the code you are. Also, it is considered bad practice to write code within the trigger itself. The good practice says that the trigger should just orchestrate the execution of methods within other classes. It's also used for defining the execution order of those methods. So it gives you a predictable execution order, which is not possible with, say, flows or process builders. This is something you might you might think of when you are planning what you're doing, for whether you're using a trigger or a flow to accomplish a certain task. Some people advocate for the use of a third element called a trigger handler, rendering the trigger just a stub. So the trigger, if you have a trigger handler, then the trigger contains just one line that calls that trigger handler, and that trigger handler contains all the logic. So it's before, or is insert, or is after, that kind of stuff. Personally, I think that's redundant, but there are many people who advocate for that third element, and you probably will see that in orgs around the projects which you'll be involved with. Before our closing remarks, let's head for some polls. First, I want you to do a quick review on the code coverage. So how many lines need to be covered in a class for it to be successfully deployed? Do you remember? I want you to cast your vote, and let's see if you're paying close attention to it. All right, yeah, votes have stopped coming in. So most of you have voted for 75%, which is correct. Some of you, one of you has voted for 95%. We should strive for 95, 100%, but the minimum required is 75%. It's the bare minimum. We should strive for covering as much as possible. Second is, what's the best practice for doing automated tests? Two of those answers are completely absurd. One of them are a good practice. Watch out. When I say that you have to make sure that just the else case is covered, that's not true. You need to cover the else case, but you also need to cover the if case. So covering just the else case is not enough. So the correct answer here is doing meaningful assertions, which really test the outcome of your code. So some things you should know about their existence, but I won't cover them here because they are lengthy topics and they should have sessions just for themselves. First is future methods. They're annotated with @future. they're queued for execution after the entire committing process is executed. So it allows for asynchronous execution. Say if you are doing a data update in the Salesforce interface in Lightning Experience, you click save, all the processes are going to run. The Salesforce will give you success and will return you to the page detail, to the record detail page. And then in the background, it's going to execute the future method. So it's executed asynchronously. It's mostly used associated with triggers for integration with external systems via callouts. So say you are sending some, say, a status of a lead to a webhook. You do it asynchronously using a callout and within a future method. Second and third are batchable classes, which you declare them as implements batchable. They are used when large data sets, over usually 1,000 records, are involved in a database operation, mostly updates. Say you are calling out an external system, or you're receiving an integration, an inbound integration from another system, which will update a large data set. You will need to implement a batchable class because it allows Salesforce to go through the records a few at a time in chunks, so you don't have to worry about hitting the DML limits. If I recall correctly, it's 15,000 lines in a single DML operation. They are typically used together with schedulable classes. For, say, you have a batch integration that runs every night and sends every record, every account that has been changed to an ERP system or something like this. So we usually combine those two. About schedulable classes, which are declared as implement schedulable, they allow programming recurring tasks in advance or with a minimum interval between executions of 1 hour. So you can have a class running every 1, 2, 3 hours, or every day, or every week, or every month, something like this. But you cannot have a class that runs, say, every 5 minutes or every 30 minutes or so. The minimum interval is 1 hour. Being there, done that, these are some, but not all, common pitfalls when you're writing an Apex code. First one is database operations inside loops. Due to the very architecture of Salesforce, we have the governor limits. So they limit query execution to 100 queries and 100 DML operations every time we are executing an Apex operation. A query should never be placed within a for while or do while loop, because if we iterate over 100 records, say 101 or 120 or 200, a single query that happens within a loop will trigger that limit and give you an exception. Same goes for an update. Second pitfall is mutually recursive triggers. Say you have one object, say account, that has a trigger that updates every contact that's tied to this account. And the contact object, on the other hand, has a trigger that updates the parent account that they are linked to. So these are mutually recursive triggers. If you don't have any criteria for the code within these triggers to run, you may end up one A triggers B, B triggers A, and so on and so forth in an infinite loop until the 122nd Apex limit times out, or you hit any other governor limits. So you should plan very carefully the execution of updates to related records. This might also lead to calling multiple future methods, multiple callouts, which will also give you an exception. So time for our last question here. What should we use to do an asynchronous callout? Say I'm calling an external system and I want to do this. What should we use? Future methods, flows, or triggers? The answer here would be future methods. That's what we use. Triggers. The trigger itself cannot do a call out. It can call a future method in order for the call out to be actually executed, but the trigger itself does not do an async call out. About flows, yes, they can do callouts, but we usually do it via future method because most of the times we need to prepare that data in order to call out these external systems. So the best answer here would be future methods. I'd like also to thank all of you for your participation and for your questions and for being here with us with all those in the past 3 weeks. Thank you once again, and have a good day, have a good evening, have a good afternoon, depending on the part of the world you're in. It has been an honor to give you this presentation, and hope to see you soon in future Ascendix webinars. Thank you guys once again.